Okay, I just wanted to run through example 5 again, just because it got kind of confusing in class. So we're trying to find the remaining zeros if 3 minus 4i is a zero of this function. So we'll go ahead and divide by 3 minus 4i to see what we have left, because we know 3 minus 4i is a zero, and we also know since it is a complex zero, meaning it has an I part to it, it does come with a buddy, 3 plus 4i, its conjugate. And so both of those would be zeros of f of x. Since one of them is, the other one has to be also. So we know we have those two guys. So we're going to use 3 minus 4i and put that into the function using synthetic division. And then we'll find out what we have left. So we will bring down that 1 and multiply it by 3 minus 4i, and we will add that to negative 6. And then we'll multiply 3 minus 4i times negative 3 minus 4i, and I'm just doing that off to the side. Going to rewrite it as negative 4i plus 3 and negative 4i minus 3, because those are conjugates. And so a plus b times a minus b is a squared minus b squared. So this is going to be negative 16 minus 9, which is negative 25. And when we add that to 28, we get 3. Multiply again, you've got 9 minus 12i, and then we have to add that. So we get negative 9 minus 12i, which we have to multiply by 3 minus 4i. And so to do that, I am going to rewrite negative 9 minus 12i as negative 3 times 3 plus 4i. And that way, when I do that multiplication, it just makes it easier, because 3 plus 4i times 3 minus 4i is going to be 9 minus 16i squared, which is going to be 9 plus 16, and that is going to be 25, and then multiplying it by the negative 3 gives me negative 75, and I get 0. So I knew that was going to happen because 3 minus 4i is a 0. And so we have x minus that 0, and then what we have left is x cubed, 1x cubed, plus negative 3 minus 4i x squared, plus 3x minus 9 minus 12i, and that's our constant. So now we just need to find the zeros of this cubic function. We already know that 3 plus 4i is going to be a 0 of that, because we know that 3 minus 4i was a 0 of the original function, and so its conjugate also has to be a 0. And so we will use synthetic division again, but this time just on the cubic polynomial, and we'll use 3 plus 4i this time. So we're going to divide 3 plus 4i into the function we have now, which is 1x cubed, negative 3 minus 4i x squared, 3x minus 9 minus 12i. So bring down the 1, multiply. You end up with 0 there. 0 times that is 0. Add them up, get 3. That's 9 plus 12i, and you get 0. So that was a lot easier than doing the first thing. So now that represents, we've got x minus 3 minus 4i, we've got x minus 3 plus 4i, and now we have x squared plus 3 left from that last division. And so we can easily find the zeros of x squared plus 3. We know that x squared would have to be negative 3, which means that x would be plus or minus square root of 3i. So our zeros are going to be 3 minus 4i, 3 plus 4i, and then plus or minus the square root of 3i. So those are our 4 zeros that we would have for this function. All right, example 6. Find a third degree polynomial, f of x, with integer coefficients and with zeros 2/3 and 4 plus 2i. So we know if it has 4 plus 2i, 4 minus 2i would also be a 0. So we're going to find that third degree polynomial, and we're going to do that by remembering that if a is a 0, x minus a is a factor. So we've got x minus 2/3, that's a factor, and x minus the quantity 4 plus 2i, that's a factor, and x minus the quantity 4 minus 2i is another factor. So these are our factors of a polynomial with those zeros. But is it the polynomial that we definitely want? We're not sure yet. Let's multiply it out. So x minus 2/3 times x squared minus 4 minus 2ix minus 4 plus 2ix plus 16 plus 4. And so if we go ahead and collect our like terms and do all the things there, do the distributive property. So that turned out to be x squared minus 8x plus 20. And now we can just multiply all that out. And we have x cubed minus 8x squared plus 20x minus 2/3 x squared plus 16/3 x minus 40 over 3. Now, that is a function with those zeros that it told us, 2/3, 4 plus 2i, 4 minus 2i, but it's not our function that we want, because the function we want has to have integer coefficients. So to make it the function we want, we can multiply the whole thing by 3 because that won't change the zeros of 2/3. 4 plus 2i and 4 minus 2i. So we're going to multiply the whole thing by 3. And now we have our f of x that we wanted, and it looks like that. Okay, now we want to find a polynomial g of x of lowest degree with zeros -2 and 4, and satisfying the condition g of 0 equals 256. So this has another condition. Fortunately, it doesn't have all these ugly zeros. It just has -2 and 4 for zeros. So if -2 is a 0, x plus 2 is a factor. And then if 4 is a 0, x minus 4 is a factor. Since -2 is a 0 of multiplicity 1, we just have one factor of x plus 2. And since 4 is a 0 of multiplicity 3, we need to have 3 factors x minus 4. So if we multiply all this out, which I didn't do in class, but we can go ahead and do that. This is what it looks like to cube a binomial. And then we can just multiply all that out, use the distributive property. We want g of 0 to be 256, but if we put 0 into that function, we're going to get -128. But I know I can multiply this function by any constant I want to. It's not going to change the zeros. It's not going to change the fact that it is a function with those zeros. If you want to figure out what that is, 256 divided by -128 is going to be -2. So if I multiply the whole function by -2, I'll have the function that I want. So it would be g of x would be -2 x to the fourth plus 20x cubed minus 48x squared minus 64x, and then that would be plus 256. So this would be the function I want. That is the function that has those zeros, and g of 0 in this case is going to be 256.